Okay, here are the integrated two notes specifically for trig applications. So these are directly inside the framework of the notes that we've been following along with so far. So let's go through and do these word problems. Okay, so we know that Aaron needs to string a bridge line across the river from point A to point B. Okay, so if we take a look at the picture, got point A to point B. I'm going to go ahead and put that in green. That's what we're looking for. Looks like it's already been identified as lowercase c. What must be the length of the bridge line given his measurements? All right, so let's take a look at what we've got here. So we've got the 67-degree angle. I'm going to go through, and we've got a 90-degree angle. That's important. Okay, across from the 67, that's going to be the opposite side. And across from the box, that's going to be the hypotenuse. And then right next to the 67 is the adjacent side. If we take a look at this, there's nothing identified on the opposite side, so we're not going to use it. So we're talking specifically about adjacent and hypotenuse. Okay, that's going to be cosine. So we know that we've got cosine of the angle, which we know is 67 degrees, is equal to the adjacent side, which we also know is 5.5, over the hypotenuse, which we don't know, which is c. Okay, so since I know the angle, I don't need to do inverse trig, so I'm just going to go ahead and set up my ratio. So I'm going to do c times cosine of 67 is going to give me 5.5. And then I need to get rid of that cosine 67. So I'm going to take that whole thing and divide both sides by cosine 67. Cosine 67's cancel on the left. Okay, so the exact length that we have is 5.5 divided by cosine of 67. But let's go ahead and get our approximate answer for that. So I'm just going to type it into my calculator. So 5.5 divided by cosine of 67. All right, this approximation is going to be 14.0761. And then I do see that this is identified as meters. So that is my answer for question number 1. All right, so we have an airplane is descending at an angle of depression. Okay, so I'm going to start drawing my picture. So I've got my plane. And I'm not going to draw the picture of a plane since art is not my strong suit. From the plane, we have the line of sight straight out. So that's going to be our line of sight. Let's make that a little bit of a dashed line. We know that there is an angle of depression of 5 degrees. So I know that from the line of sight down, that's going to be a 5-degree angle. Okay, then let's take a look at the rest of this. If the horizontal distance to its destination is 500, okay, so horizontal, if we go straight from where the plane is, you know, its horizontal is going to be that bottom part. So its horizontal is 500 kilometers. I want to think that straight down, remember a height is always going to be perpendicular to the base. What is the actual distance the plane will travel before it lands? Okay, so let's think about this. We've either been on a plane or we've seen a plane. We know that planes don't drop straight down. So it's not going to be this vertical distance that I just identified as x. It's not going to be that. So that's not how planes run. Planes... To land, if you're above ground, you're going to have to slowly go down. So I think we're talking about this distance here. So let's talk about actual distance. All right, I'm going to call this D just for distance. So I think it's this green path that we're actually talking about. We want to figure out that distance. Okay, so let's see. We can actually draw this triangle a different way. Let's go ahead and bring the height up here. Then I know that this will also be a right angle up in the top. And I think I can pull the 500 kilometers straight up as well. Okay, now we're talking. So I've got this triangle on the top. So if I were to highlight it, this is the triangle that I'm looking at up here. Okay, so starting from the angle that I know, I would want to identify my sides. It looks like I have the hypotenuse, that's the length D, and then it looks like I have the adjacent side. So I've got adjacent and hypotenuse. That sounds like cosine to me. So cosine of my angle, which I know is 5 degrees, is equal to adjacent, which is the 500 kilometers, over hypotenuse D. All right, I'm looking for a length, so I'm just going to go ahead and set up my ratios and cross multiply. And then divide by cosine of 5. Remember, we're trying to find that length D, so that distance. Cosine 5 divided by cosine 5 is 1, so they cancel. So we'll get 500 divided by cosine 5. Okay, that's my exact answer. Let's actually find out the approximate. So we're going to type in 500 divided by cosine 5. So that's going to give me 501.9099 kilometers. So it looks like that is going to be the distance that the plane is actually going to travel. Okay, moving on. Let's take a look at question number 3. Let's see, a ramp with a length of, okay, so a ramp. Ramp normally goes up or down at a specific angle to the ground. It's got an angle of elevation. Okay, so here we go. Let's draw our picture. So here's the ground. And then our ramp is going to go up. Not sure how steep it's going to be. So the ramp with a length of 21.2. So that's going to go right there since that's our ramp. Has an angle of elevation of 15 degrees. Okay, remember, angle of elevation is looking up or going up. So from the ground up, that's going to be our 15 degrees. All right, what are we trying to find? How high up does it reach? Okay, so we're actually looking for the height right now. So I think we're looking for that. So why don't you see if you can set up the ratio with your sine, cosine, or tangent, whichever one it is, and see if you can solve. Come back and check your answer. Okay, so it looked like it was the sine ratio in this question. Went ahead and set it up. I'm not looking for an angle. I already know what that is. So I set up my proportions, and then I cross multiplied, and I solved. Okay, with this one, I think one of the things that can be pretty tricky about these word problems is actually coming up with the picture. So my recommendation at this point, see if you can draw the picture for question number 4. Then come back and check the picture. So pause it now, see if you can do the picture, unpause, check the picture. Okay, so here's my picture. I went through and I added in where the string would be, where the balloon is located, and the ground. And then I color-coded where I put the corresponding information into the picture. Now that we have the picture, you go ahead and see if you can figure out what y is. Okay, so I got 8.6036 for this. Okay, so 5 is a lot like 4. Just see if you can do the entire thing. So draw the picture and then see if you can answer the question. So pause now, give it a shot, come back, check your work. Okay, double check your work against mine on question number 5. And then from here, this will actually finish up this portion of the notes.